Dear students, having introduced the cost functions and factors determining the cost functions, we now consider the properties of cost functions. The first property that we consider is homogeneity. Homogeneity. The total cost functions in the examples given associated with the fixed proportions production function, Cobb-Douglas production function, and CES production function are all homogeneous of degree 1 in input prices. The total cost functions are all homogeneous of degree 1 in input prices. It means that if the input prices are doubled, the cost of producing any given level of output also doubles. If the input prices doubles, the cost of producing any given level of output also doubles. And this is a property of all the proper cost functions. This is a property of all the proper cost functions. That is, cost functions are homogeneous of degree 1. Doubling of input prices doubles the cost of producing any level of output. And this property is known as homogeneity. And we know that when all the input prices double, if all the input prices doubles, the ratio of input prices will not change. The ratio of input prices will not change. And the cost minimizing input choice is given as MRTS is equal to W by M. That is, MRTS is equal to W by R is the cost minimizing input ratio. So, as W by R will not change, it also means that in equilibrium as MRTS is equal to W by R, then cost minimizing input combinations also will not change. That is, K by L will remain same. So if input prices doubles, then cost minimizing input ratio also remain same. That is, the firms will use the same combination of capital and labor to produce any level of output. So, if W and R doubles, the firm will purchase the same amount of capital and labor and give double wage and double interest, and K by L ratio will remain the same. Now, one implication of this property is that if there is a uniform inflation in the economy, uniform inflation in the economy means if all the factor prices are increasing in the same ratio, firms' input decisions will not change. firms' input decisions will not change if there is uniform inflation. Remember this, if either W or R changes, we will not have this conclusion. We are talking about homogeneity when what happens to both the factor prices. So, as a result of the increase in input prices, cost curve will shift upwards in precise correspondence with the rate of inflation. Cost curves will shift upwards. The same K by L ratio will be maintained, but cost of producing any given level of output increases in the same rate as the rate of inflation. So that is the first property. Total cost functions are homogeneous of degree 1 in input prices. In input prices. First property. A second property is that total costs functions are non-decreasing. This is homogeneous in W and R. A second property is total cost functions are non-decreasing in Q, W and R. Total cost functions are non-decreasing in output and input prices. This property, though it is obvious, requires some explanation. And remember this, cost functions are derived functions. Cost functions are derived from cost minimizing input choices or cost minimizing process. If you are deriving the cost functions from the expansion path, it is known to you that each point on the expansion path is a point of cost minimization. So, as cost functions are derived from cost minimization process, and if there is a decline in cost when output increases, if there is a decline in costs when output increases, wage increases or R increases, that is, if there is a decline in cost, if any of these arguments increases, there is a contradiction. Now, suppose that there is an increase in output from Q1 to Q2, an increase in output from Q1 to Q2, and cost declines. What does that mean? That means the firm was not minimizing cost in the first place. The firm was not minimizing cost in the first place. Now actually, if a cost decreases, if output increases from Q1 to Q2, suppose for producing Q1, cost was 100. When output is increased to Q2, cost decreases to 80. Then it is better for the firm to produce Q2 output at a cost equal to 80 and throw away the difference between Q1 and Q2. And throw away the difference between Q1 and Q2. So we can say that total cost is non-decreasing in Q, W and R. So when you draw a total cost curve, it must be continuously increasing in Q as we generally draw. It must be non-decreasing in Q, similarly non-decreasing in W and also R. Also, If increase in the price of any input reduces cost, its implication is that firms were not minimizing costs at the first place. That is an implication. Suppose that the firm was using a combination K1 L1 to produce a level of output Q1, and using K1 L1 to produce Q1. When output is increased to Q2, then cost decreases means this combination was not the optimum combination. So it will give contradictory results. So the conclusion is total cost functions are non-decreasing in Q, W and R. Now, a third property is total cost functions are concave in input prices. Total cost functions are concave in input prices. Input prices. Total cost functions are concave in input prices. It is easy to understand this property with a graph. Let us consider total cost and the relation between total cost and wage. Total cost is concave to input prices means concave to W, concave in W and concave in R individually. Concave in W and concave in R individually. This is homogeneity is specified in terms of both W and R. This is a different property. This is concave in W and concave in R. Now, suppose that we consider total costs for various values of an input price, say W. Total cost for various values of an input price W, keeping constant R and Q. R and Q held constant. Now suppose that initially input prices are R1 and W1. Input prices are R1 and W1, and also assume that the total cost associated with the Q1, total cost associated with producing Q1 is given as C R1 W1 Q1. C W1 and total cost associated with the producing Q1 is given as C R1 W1 Q1. That is, initially we assume that factor prices are R1 and W1, and to produce Q1, cost is given as R1 W1 Q1. To produce a given level of output, C is given as R1 W1 Q1. Using the cost minimizing combination L1 K1. Using to produce Q1, the cost minimizing input combination is L1 K1, and the associated total cost is R1 W1 Q1, assuming that initially price of capital is R1, price of labor is W1. Now suppose that the firm did not change the input mix in response to a change in wage. Suppose that wage changes, R1 remaining the same, W1 alone changes. Then suppose also that the firm will not change the input mix, that is K by L ratio, in response to a change in wages. Then the total cost curve will be linear. The total cost curve will be linear, given by the linear total cost curve C. We denote this linear total cost curve as C pseudo. C pseudo. This total cost curve is the pseudo total cost curve if for a change in W, keeping R1 constant, the firm is not changing the input mix to produce the given level of output Q1. So C pseudo is represented as C R1 W Q1. W is now a variable. C pseudo is given as C R1 W Q1. C R1 W Q1 is given as R1 K1 plus W L1. Cost is R1 K1 plus W L1. The input mix is L1 K1. That is the total cost. R1 is constant. Now W is a variable. W changes. Input is not minimized. But we expect that for a cost minimizing firm, when the price of factor labor changes, a cost minimizing firm will change the input mix. The cost minimizing firm will change the input mix and the actual costs fall below the pseudo cost. The actual costs fall below the pseudo cost. That is C R1 W Q1. If in response to a change in W, if the firm actually changes the input mix, the actual cost will be lower than the pseudo. So the C R1 W Q1, the actual cost curve will be lower than the pseudo cost curve. Pseudo cost curve is a linear curve. So C R1 W Q1, that is the actual cost, lie below the linear, the pseudo cost curve if the firm is not changing the input mix. So we will say that cost functions are concave in input prices. Cost functions are concave in input prices. So the actual cost curve fall below the pseudo cost curve, provided that input mix is not changing. Now, one implication of this finding is that costs will be lower when a firm faces input prices that fluctuates around a given level than when they remain constant at that level. One implication is input is that total cost will be lower when a firm faces input prices which fluctuate around a given level rather than remaining constant at a particular level. And with the fluctuating input prices, a firm will adapt its input mix to take advantage of such fluctuations in input prices by using more labor when its price is low and less labor when its price is high and vice versa. So, total cost will be low if the factor prices fluctuates around a particular value rather than remaining constant. So these are the three properties of total cost functions. Homogeneity, homogeneous of degree 1, non-decreasing in QW and R. We have stated that cost is a function of QW and R, and total cost is concave in input prices R and W. Now a question is whether these properties will be transferred to marginal and average costs. The answer is some, but not all of these properties of total cost functions will carry over to MC and AC curves. Some of the properties will be carried over to MC and AC, but not all. Consider the first property, homogeneity. Homogeneity of the total cost curve will be transferred to MC and also AC. Let us see how. Since C, TR, TWQ is equal to T into C, RWQ. AC is equal to, we know that total cost is homogeneous of degree 1. So multiplying R and W with a constant, cost is T times the original cost. AC is equal to TR, TWQ is equal to C of TR, TWQ by Q. AC is equal to T of C RWQ by Q is equal to T of AC RWQ. And AC is CRWQ by Q, and it is equal to, and if you multiply R and W with T, AC increases in the same proportion. So AC is homogeneous of degree 1 in W and R. MC of TR, TWQ is equal to dou C TR, TWQ by dou Q is equal to T into dou RWQ by dou Q is equal to T times MC of RWQ. So marginal cost is also homogeneous of degree 1 in W and R. So the first property of total cost functions is transferred to the MC and AC. Then the effect of, what about the second property? What about the second property? That is, total cost is not decreasing in Q, R and W, but the effect of change in Q, R and W on AC and MC is sometimes ambiguous. The reason is AC and MC curves have negatively sloped segments. So neither AC nor MC is non-decreasing in Q. We cannot say that MC and AC non-decreasing in Q because there are decreasing segments. That is not satisfied. What about the second? TC will not decrease when there is an increase in W and R. So it follows that AC is increasing in W and R. As TC is non-decreasing in Q, so in W and R, average cost is also non-decreasing in W and R. Average cost is non-decreasing in W and R. There is some ambiguity regarding MC if there are inferior inputs, but generally we will say that MC is also non-decreasing in W and R. MC is also non-decreasing in W and R. So remember this. Homogeneity is transferred to MC and AC. The second property, TC is non-decreasing in Q, not applicable in the case of MC and AC, but TC non-decreasing in W and R is applicable to AC and MC. Now these are the properties of cost functions.